Before we get into finding partial derivatives, which will be the derivatives of multivariable functions, we want to cover some notation and talk about how this relates to previous topics we've already covered. So we already have the derivative notation, f prime of x, which we could also rewrite as d over dx, f of x, or df over dx. All of those mean exactly the same thing. Find the derivative of a function f of x. Now for partial derivatives, we need to indicate which variable we'll be differentiating with respect to, because we have two different independent variables. So we could find f sub x, x comma y. That would mean find the partial derivative with respect to x. We could also rewrite this with a notation that's similar to that d over dx notation, but instead it'll be sort of a cursive d, which we refer to as the Greek letter delta. So delta over delta x of f of xy would mean take the partial derivative with respect to x, or we could write delta f over delta x, mirroring that notation that we have, that we've already established. Now if we wanted to differentiate with respect to y, we would make a small change to each of those notations. We would write f sub y, or delta over delta y, or delta f over delta y. So whether we have an x or a y in that partial derivative statement, that's going to tell us a slightly different approach to take to the problem. We also have derivatives that we use for, or notation that we use for the second derivative. We could write f double prime of x, meaning find the second derivative. We could write d squared over dx squared f of x, or d squared f over dx squared. All of those notations tell us to find the second derivative of a function. For partial derivatives, we have to indicate at each step which function we're differentiating with respect to. So we could take the first partial derivative with respect to x, and then the second partial derivative with respect to x. Or we could take the first partial derivative with respect to x, and then differentiate with respect to y. Or we could start off by differentiating with respect to y, and then y again. Or we could differentiate with respect to y, and then x. So we're not talking about how these notations necessarily change the problem yet, just the idea that we need to be aware. We need to pay close attention to that notation, because that's going to inform how we approach the problem. That is, when we differentiate multivariable functions, we need to treat one letter as a variable and the other as a constant. That will be the difference that comes into play depending on that notation. And we'll see in a minute examples of how that works. So this idea of treating one letter as a variable, the other as a constant, is the idea that we're differentiating part of that function. That's where that idea of partial derivatives comes from. But we need to keep in mind that all of our previous rules and properties still apply. All that's changing is that we have more than one independent variable, and we'll be focusing on one of those variables to differentiate with respect to. So that means the sum and difference rule, the product rule, chain rule, quotient rule, all of the previous techniques that we have will be applied to these examples that we look at.